Two thrill seekers, Carly and Ben, are each attached to straight wires that allow them to slide down within a wide canyon. A coordinate system is defined showing the positive coordinate axes, with O being the origin. At exactly 10:30 a.m, Carly is at a position of negative 200i plus 300j plus 700k meters and is sliding down her wire with a velocity of 2i minus j minus k meters per second. Meanwhile, Ben is at position 500i minus 200j plus 800k and is sliding down his wire at a velocity of negative 0.5i plus j minus 1.5k meters per second. Now, anybody who's ever watched any of my videos knows how much I hate I, j and k. So I'm going to have R for Kylie, and I'm going to do it in column vectors. So that would be negative 200, 300, 700, and t, and her velocity is 2, negative 1, negative 1. See how much better that looks than all those i's and j's and k's. And then we've got Ben, and he's at 500, negative 200, 800, and his velocity is negative 0.5, 1, negative 1.5. Determine Ben's speed correct to the nearest 0.01 meters per second. Well, his speed is just going to be the magnitude of this velocity. So that is simply the square root of 0.5 squared plus 1 squared plus 1.5 squared. We don't need to worry about negatives because we're squaring. And that gives us 1.87 meters per second, correct to the 2 decimal places required. Calculate the angle of Ben's descent to the horizontal, correct to the nearest degree. Well, it's probably easier to work out his angle to the vertical, since the vertical is just 0, 0, 1. And so if we work out that angle, we'll then be able to work out the angle to the horizontal, whichever direction it's in. It could be this way. So his direction is negative 0.5, 1, negative 1.5. So we can work out the angle between those two vectors. We can do that using a dot n. So, sorry, let me think about that again. Yeah, a dot n is equal to mod a mod n cos theta. So cos theta is equal to a dot n divided by mod a mod n. And so if we dot these two vectors, we just get negative 1.5. And we just worked out the modulus of a, which is the speed, the 1.87, which isn't exactly that. I'll probably use a more accurate figure when I do the calculation, and of course the magnitude of this one is just 1, and so theta is going to be the inverse cosine of that, and that comes to 143.3, and so that means it was down here, and that was 143.3, and so the angle to the horizontal there is just going to be that take away 90. So angle to horizontal is going to be 53.3 degrees. And we wanted that to the nearest degree, so 53 degrees to the nearest degree. Okay, great, let's move on. It was found that the closest that Carly and Ben approached one another was approximately 57.74 metres after 266.67 seconds of motion from 10:30 a.m. Suppose that Ben is able to adjust the speed of his descent and the time at which he commences sliding down his wire. Calculate the minimum distance, correct to the nearest 0.01 metres, that Ben could be separated from Carly if he was able to adjust the speed and timing of his motion. Show all evidence of your working. So my initial thought is that what we want is the shortest distance between the two zip lines, assuming that Carly will be here at some point and that Ben can adjust his speed so that he's here at the same time. Given that Ben can vary the time at which he leaves, we can use different parameters for the lines that they go along. So for Carly, negative 200, 300, 700. So negative 200, 300, 700. And that's going to be plus, so her velocity was 2, negative 1, negative 1. So let's say that's plus 2 lambda, minus lambda, minus lambda. And then for Ben, we will have, so Ben, 500, negative 200, 800. Was 800, was it negative 200? I'll check when I go back up. Yeah, and negative 0.51, negative 1.5. So that'll be take away 0.5 mu plus mu and take away 1.5 mu. Now we do have an E-activity that will do this. Shortest distance between two lines, and just put things in here and it'll do. But it does say it wants to show evidence of our working, so I'm not going to just use that. There is a formula which is A2 take away A1 dot n divided by mod n, which I do teach in the course that I do. I think formula either stated like that or very similar is in one of the instructional videos. And the n here is mutually perpendicular to these two. So in other words, to get the n, what I need to do is a cross product of 2, negative 1, negative 1, and negative 0.5, 1, negative 1.5. Now, let's do that. And so covering up the I, we get 1.5, take away negative 1, so that would be 2.5. Covering up the J, we get negative 3, that's 2 times negative 1.5. Take away 0.5, so what was that again? That was negative 3. Take away 0.5, so that's take away 3.5. This one has to be the negative of what we get. And then covering up the K, we're going to get 2. Take away 0.5, so that is 1.5. And the A2 take away A1, it really doesn't matter which way round we do this. That would be 500, negative 200, 800. Take away negative 200, 300, 700, and so that is 700, negative 500, 100, like so. And so we are going to have 700, the distance is equal to the modulus of 700, negative 500, 100, dot 2.5, 3.5, 1.5, all over the square root of 2.5 squared plus 3.5 squared plus 1.5 squared, and let's see what that comes out to. And that comes to 32.93 meters. All sorts of different ways of doing that. Generally, I'm not a big fan of remembering formulas, but this one is a useful one because figuring out how to do that on the fly in the middle of an exam is not going to be fun. So having a formula to hand is good.